Carbon tetrachloride was prepared by reacting 100 grams of carbon disulfide. So here, carbon disulfide is this one. And the problem is giving me 100 grams. And also 100 grams of chlorine, okay? So here I have the chlorine and here I have 100 grams. So calculate the percent yield if 65 grams of carbon tetrachloride were obtained from the reaction CS2, chalala, chalala, chalala. So how can we understand this problem? So it says, calculate the percent yield. So in that moment, you know that you have to apply the formula for percentage yield. And they're giving you this condition. If 65 grams of CCl4 were obtained, okay? So this, you can understand it as those 65 grams were obtained in the lab. That's how you understand that part of the problem, okay? So you write the equation and you write all the information that you need from it. You had 100 grams from each reactant, and you know that in the lab you got 65 grams. And I want you to analyze this. The givens are in grams, and the yield is given in grams. Okay? So, in the end, you're gonna have a conversion between grams and grams. And I gave you the other day a path to follow in case that you have to apply stoichiometry for mass to mass conversions. Okay? The path is from grams given to moles given to moles unknown to grams unknown. That's the path that I follow, okay? So this path is going to help you to do the process. So I did the process of the molar masses. I know that CS2 is 76 grams per mole, so I put it here. I know that Cl2 is 70.90 grams per mole, and I know that carbon tetrafluoride is 153.8 grams per mole. So I have all the information I need, which means that I can start working with that problem. Because I don't know which one is the limiting reactant, I have to get it. Now, what reactant is the limiting? Okay, what tells you the limiting reactant? There's an indicator to know the limiting reactant. Take a look. Here, the two givens are the same amount of mass. So the limiting reactant, you cannot get it directly from the equation. You have to do a procedure. So the procedure is that you need to work with both reactants, with the reactant 1 and reactant 2. Now the reactant 1 that I have in the equation is CS2. So I'm going to start working from that. Well, you don't need to see the procedure for the molar masses, so I'm going to focus on this. Okay. Shayla, your camera on, please. Dulce, your camera on. So you say 100 grams given of CS2. So in the path, you have grams and moles. Between grams and moles, what do you have to use? Molar mass or molar ratio?
Molar mass.
Molar mass. So you say the molar mass of which one? Of the given.
Given.
Okay. And the molar mass of the given is 76 grams of CS2 in 1 mole of CS2. You cancel the same units and you continue. Now, the problem gives you moles given to moles unknown. What do you need for that?
Molar ratios.
Molar ratios, okay? So here you will use molar ratio. Between what? Between the given and the unknown. So what is the molar ratio that we have between the given and the unknown? How many moles of CS2 I'm going to write?
1.
Invisible 1 mole of CS2. And how many moles of carbon tetrachloride?
1.
Also 1. And now we go to the last part. That is from moles unknown to grams unknown. What am I going to use? Molar mass or molar ratio?
Molar mass of the product.
Molar mass of the product. Okay? So this will be in 1 mole of CCl4, you have a molar mass of 153.8 grams of CCl4. Okay, I just want to say this, in which number 9 is 20%. So to make sure that you are actually understanding this, I will assign individual problems that you will record yourself as it was an exposition, okay, to see if you understood the problems. And it costs 20%, so if you're not paying attention, you better want to change your mind. So how much is this?
202.37.
202.37, and the units are grams of carbon tetrachloride. Okay, to see if that is the limiting reactant, I have to compare with the other reactant. So I continue with my second reactant. So I say my second reactant, that is chlorine, and I begin with the conversion. The path is the same, from grams given to grams unknown. So I have 100 grams of chlorine and again I follow the path. From grams given to moles given, I need the molar mass. So in 1 mole of Cl2, I have a mass of 70.90 grams of Cl2. I cancel the units. Now, from moles given to moles unknown, I need to use what? Molar mass or molar ratio?
Molar radius.
Molar ratio.
Okay. How many moles of chlorine?
3.
3. 3 moles of Cl2. Okay. And how many moles of carbon tetrachloride?
1.
Invisible 1, okay? You don't see it, but it's there, invisible 1. So 1 mole of carbon tetrachloride. So here you cancel the same units and you continue. And now, from moles unknown to grams unknown, you need to use the molar mass of the unknown. So the molar mass of the unknown is the same, 1 mole of CCl4 that has a mass of 153.8 grams of CCl4. How much is this?
72.31.
72.31 grams of CCl4. So according to both products, according to both products, how much I can obtain, 202 or 72?
72.
72, always the least, okay? So according to the procedure, the 72 is what you get theoretically. And why is that? Because in theory, the limiting reactant gives you what you get theoretically, okay? So in this case, Cl2 is going to be the limiting reactant. If this is the limiting reactant, what you obtain from the limiting reactant is what you get theoretically. Always comes from the limiting reactant, okay? Remember this, from the limiting reactant. So what happens after you know where you should get theoretically? After you know what the limiting reactant is and you should know how much theoretically you should obtain, you can now apply the formula for percentage yield, okay? So percentage yield is equal to actual divided by theoretical times 100. Remember that actual is what you got in the lab, and theoretical is what you got from the limiting reactant times 100. So this is going to be equal this is going to be equal to what you got in the lab, that is 65 grams of carbon tetrachloride divided by the limiting reactant product, that is 72.31 grams of carbon tetrachloride times 100. You eliminate the grams of carbon tetrachloride with grams of carbon tetrachloride. And how much is this?
89.89.
89.89%. In other words, the limiting reactant tells you how effective your reaction was. You were expecting to get 72 grams, okay? Because that's what you should get in theory. But instead, you just got 65. So how effective the reaction was? Almost 90% effective. So in other words, this tells you how effective your reaction was. And that's it. You can see the percentage yield is something very, very easy to apply, but you have to apply everything you know of stoichiometry, grams to grams conversion, grams to moles conversion, what you need, okay? And you also need to apply what you know about the limiting reactant. So this is a whole concept, whole process. And of course, you will do this kind of exercises as part of your exposition for the week 9. And this is it for this problem. Now let's work with this one. It says, silver bromide was prepared by reacting 200 grams of magnesium bromide and an adequate amount of silver nitrate. Calculate the percent yield if 375 grams of silver bromide were obtained from the reaction, and there you go, you have the reaction over there. Okay, so now we need to work with this word problem. We need to gather the information. It says silver bromide was prepared. Now, in that part, the problem tells me what is the product that I care about. So silver bromide in this case is the product, okay? The product that you will work with, okay? So silver bromide was prepared by reacting 200 grams of magnesium bromide. So the problem also gives me 200 grams of magnesium bromide, which means that I will write that information in the reaction. Magnesium bromide is which one? 1, 2, 3, or 4? Which
One.
one? Okay.
One.
Yes, it is 1. Okay, so write the information over there. 200 grams. Now, the problem also says, and an adequate amount of silver nitrate. Which one is silver nitrate? 1, 2, 3, or 4?
4. 2. No, 2.
2. Okay, silver nitrate is number 2. So the problem tells you adequate amount. In other words, that means that silver nitrate is the excess reactant. It's just another way to specify that silver nitrate is the excess reactant. If silver nitrate is the excess reactant, which one is the limiting reactant?
Magnesium bromide.
Magnesium bromide. You have only 2 reactants, one is in excess, so the remaining reactant is going to be the limiting reactant. So in this case, the problem is already given us, not directly, okay, but it's giving us the limiting reactant. And what depends from the limiting reactant? The theoretical yield or the actual yield? Which one depends from the limiting reactant? The theoretical
Yield.
Theoretical.
the theoretical, okay? So basically, the problem by just giving you the limiting reactant is telling you that you should work only with that reactant because the other one is in excess, okay? So you're gonna focus only in the limiting reactant because that one is the one that matters, remember? We care about the limiting reactant. So, now, according to the word problem, it says, calculate the percent yield if 375 grams of silver bromide were obtained. Those 375 grams, is it the actual yield or the theoretical yield?
Actual.
Okay, this, when it says were obtained, means that the 375 are obtained from the lab. Okay, so which one is silver bromide? 1, 2, 3, or 4?
4.
4, okay? So, in other words, the product that I care about is just silver bromide, which is this one. And in the lab, I obtained 375 grams. So I want to know, even if the problem is not telling me, I want to know what I can get theoretically. Because if I want to know the percent yield, I need to know what I can get theoretically, okay? So I begin my problem by saying, well, by analyzing the units, okay? The given and the unknown. The given is in grams and the unknown is in grams, which means that you're gonna be working with a grams to grams conversion, okay? Grams to grams conversion. Okay, so the grams to grams path that I gave you is this one. From grams given to moles given, from moles given to moles unknown, and from moles unknown to grams unknown. Okay, that's the path that you follow. So you begin with your given. I'm also missing the molar masses, sorry. So I'm gonna need the molar masses of which one? The given and the unknown. So I need this molar mass and this molar mass too. So my calculation for molar masses, I'm gonna do it very fast. MgBr2 and AgBr. So the molar mass is 1 times magnesium. Sorry guys. I can't focus when someone else is talking. So magnesium mass is 24.305. You're not seeing the procedure, sorry. Okay, and if this is 1 magnesium and 2 bromines, okay? So this is 1 times 24.305, and this is 2 times 79.90. The molar mass is how much, Shayla? Cannot wait for you. 184.11 grams per mole. For silver bromide, I have 1 silver and 1 bromine. Okay, so it is 1 times silver's silver's atomic mass, that is, let's see, 107.87, and bromine, that is 1 times 79.9. How much is this?
295.64.
The second one,
I got 187.77.
187.77.
187.77. Check the process that you did, okay? Always make sure that your answers are correct. So just write the data that you know. This is 184.11 gram per mole, and this is 187.77 gram per mole. Okay? It's gonna move this. Okay, now I do my process. So they are giving me 200 grams of MgBr2, magnesium bromide, okay? So from grams to grams, remember that process. From grams to moles, you use the molar mass. So it is in 1 mole of MgBr2, you have a molar mass of 184.11 grams of the substance. Then from moles given to moles unknown, you need to use molar ratios. What's the molar ratio between the two substances? How many moles of magnesium bromide?
1.
1 mole of magnesium bromide. How many moles of silver bromide?
2.
2 moles of silver bromide. And then I continue with the other step, that is from moles unknown to grams unknown, that is molar mass of the unknown. So in 1 mole of AgBr, I have 187.77 grams of AgBr. How much is this? How much is this?
$407.95.
407.95 grams of AgBr, silver bromide. Okay, because this is a limited reactant, because the problem is already telling me that this MgBr is a limited reactant, this is what we get theoretically, okay? So theoretically, you get 400, almost 408 grams. So now that you have what you get theoretically, you can get the percent yield. So the percent yield is equal to the actual divided by what you got theoretically times 100. The actual is what you got in the lab. Okay, so it is 375 grams of silver bromide divided by what you can get theoretically, that is 407.95 grams of AgBr times 100. How much is this? How much is this?
91.92.
91.92%. That means that the reaction that you did in the lab was almost 92% effective. So 92 is a very good score, okay? It's a very good percentage. So the person doing that reaction is doing very well, actually. So as you can see, the application of the percentage yield formula is very, very easy to do. And this is it. So analyze the problem and tell me if you have a doubt in any of the steps.
Yes.
Yes?
When you know when you are going to find grams to grams or grams to mole.
Can you repeat that question, please?
How you know when are you looking for grams to grams or
Because of the
you are going
information. The information of the problem. Here, for example, they are giving you 200 grams, and also you obtain in the lab 375 grams. Okay, so from grams to grams, you have to do this process, all this path. That depends on what the problem is giving you. Usually for percentage yield, the conversions are always going to be grams to grams, because in a real lab, you're going to measure the masses in grams. That's